This is the micro engine's inlet manifold, and like almost everything on this engine swap, it won't just bolt in place. The issue with this inlet manifold is mainly in this area here. When fitted to the engine, this clashes with the bulkhead. Now, fortunately, it is aluminium, which means we can cut, weld and modify it in order to make it fit. First thing we need to do though is strip this one down. Now we have the manifold stripped down, the next step is to trim this down into shape. The bit we're mainly interested in is this front section here that holds the injector bosses and the flange that bolts onto the engine. Everything back, we're going to modify. Now we're going to go proper old school on the cutting of this manifold for two reasons. One, get a neater, straighter cut with a hacksaw. Second of all, this is aluminium, so it shouldn't be cut with an aluminium oxide grinding discs. Yes, you can get silicon carbide, but I currently don't have any in, and I'm happy to do this with a hacksaw. Anybody want half a micro inlet? Now that the micro inlet manifold has been cut back and finished back to get it reasonably flat, the next job is to fit this to the engine. We can then start looking at building the upper part of the plenum to which the throttle body joins us on to the end. Now I'm going to save myself a lot of work by modifying this to a Starlet inlet manifold. After comparing the Starlet manifold in position relative to the what's left of the micro inlet manifold, the cut needs to be somewhere about here in the middle. So we should get it underneath the bonnet, and we'll also bring it far enough away from the bulkhead that everything clears. The only issues you might be able to see is that while the two middle runners line up with the micros, the outer two are probably inboard by about ½ an inch. So strange as this might sound, I'm actually going to cut the outer two much shorter back here, around here, because that will allow me to rotate them, and if I leave all of this intact, I can later on trim this end to make it fit. So first thing, let's cut that, and through the flange there. Well, I'm an idiot and I forgot to hit record while I was cutting the outer two runners off. Unfortunately, there's no going back. I can't restage it and show you, so I'll just have to show you the middle two. I've just done a final check on the car and roughly worked out that the position needs to be pretty much smack bang in the bottom of this U section. So I'm going to try and cut it in this position, which will line up with the ports. Now I will be completely honest with you, I am a completely self-taught welder. It probably shows. And my experience with aluminium is basically naff all. I basically experimented around with a piece of scrap here with my new cheapo Chinese AC/DC machine and have successfully tack welded this to the manifold. I am hopefully going to get some tuition and a bit of help with the setup on the machine from some colleagues at work who are professional welders. So for the time being, we are just going to tack weld the two halves of the manifold together. But I'm confident enough that should work. Now, the key to any good weld is cleanliness. So we're going to take a few minutes to properly clean everything back and decrease all the insides of the runners. When you're degreasing them, be careful of the materials you use. If you use certain brake cleaners that can give off some quite nasty gases afterwards, I tend to use acetone because it doesn't do that. Also, I'm going to take off a few of the casting marks on the micro in that manifold because they're going to be very close to where the weld are and they're just going to be awkward to get around them. So that's what I'm going to do now. Yeah. With the two halves of the inlet manifold tack welded together, and this has been test fitted onto the car to make sure it clears the bulkhead and the underside of the bonnet, we can now look at completing the two outer runners. So this is going to require an awful lot of cutting, grinding, and welding. Now that the manifold is all tacked together, we can move on to the job of fitting the throttle body. This is the throttle body, complete with aftermarket air filter from the Nissan Micra donor car. There's a few reasons I want to use this, even though this won't bolt on directly to that manifold. First of all, I don't want to have to go out and find a starlet throttle body. I don't have one, I've just got the manifold. Secondly, this throttle body has all the necessary sensors to work with the Mikra's ECU to run this engine. In addition to that, we also have the wiring loom that is from the donor vehicle that is terminated for these sensors, so that's going to save us quite a bit of work. As I said, unfortunately this won't bolt on, so we've now got to look at making an adapter flange to go from this throttle body to the starlet manifold. My aluminium welding is in its infancy, so we're going to make an adapter plate rather than weld a flange on, because if I welded it, I'm most likely going to distort that plate and therefore the throttle body wouldn't seal. My dad, once again, has come to the rescue. He managed to find a piece of large diameter aluminium bar and very kindly faced it off for me, so I've got the material to make the adapter flange. As I've only got one shot at doing this though, I'm going to first of all make myself a template out of a piece of MDF. After making the MDF mock-up adapter plate, and yes, they were even tapped so I could bolt everything together, although I will admit it took me more than one attempt to do this, I proceeded to take some very careful measurements and create myself a detailed drawing that I could use later on.
began making the adapter flange by roughly cutting it to size. As you'll see in a minute, I did machine the sides of the adapter flange to get them nice and straight. However, cutting it down closer to size reduced the amount of machining I had to do, and ultimately the amount of cleaning down in the milling machine afterwards. Machining the sides of the adapter flange not only made it look nicer, but also gave me a set of edges that I could datum the machine off of. This allowed me to drill all the necessary holes in a precise location, ensuring that everything went together properly. Now, there are a few ways to datum a machine. What you're about to see is one of the most basic ways, and while it's not the most accurate way of doing it, it's sufficiently accurate for what I needed to do. First step is to know the diameter of the cutting tool or the drill that you're using. If you miss this, trust me, it's going to cause you some problems later on. Once you've noted the diameter of your cutting tool / drill, you'll next need to stick a small bit of paper onto the sides that you act as your datums. I often use the corners of my own drawings and simply lick them to stick them to the workpiece. All you do then is carefully wind in the machine until your cutting tool / drill knocks the piece of paper off your workpiece. Wait for it, boom! Now we know exactly where the cutting tool centre line is in relation to the edge of the workpiece. With the machine datum set, I referenced the drawing that I made earlier and drilled the holes for the throttle body to mount to. Now, it would have been sensible to set the workpiece up in the miller, mill the sides, drill all the holes in one go and create all the countersinking, etc. Unfortunately, I was making this across a week's worth of lunch breaks and had to make sure that the machine was always free at the end of my lunch break, ready for the afternoon shift. This did mean I had to keep taking it out, and yes, that meant I had to keep resetting up datums, so the order and operations that were used to create this part may seem a bit out of order from what you'd expect. A 10mm wide slot was required. Yep, in hindsight there was a better way of making this, however the way I started making this was by drilling a 10mm hole. As a rule of thumb, 8mm is about as big as you want to go when drilling something before you require a pilot hole. Obviously as this hole was 10mm, I required a pilot hole. Next we ventured to the lathe to drill a big hole in the middle that lines up with the throttle body. This hole started out by using the biggest hole saw I had up to the size that was required, and then was finished off by using the boring bar. This lathe will make a much bigger appearance in a future up and coming episode. As I said earlier, the order in which this part was made was a bit all over the place. Normally I would have countersunk the holes when it was in the milling machine, however due to time constraints and having to take it out of the milling machine, they got done by hand afterwards. They may not be as neat as what I possibly could have got them, however they are adequate for what is required. Had the aluminium plate actually been thicker, I probably would have countersunk them, I probably would have used a set of cap head screws and counterbored the holes instead. And finally, cutting out the slot that is required. If anybody wants to see more detail on how this part was made, please leave a comment below. I may upload all the footage that I took while making this part. You have been warned though, it is hours worth of work.
As you can see, the manifold and the throttle body have various pipe outlets. Some of these need to be connected up on the car, and those that aren't required will need to be blocked off. The first two are these two. These take in a water feed from the cooling system and pass through the to the throttle body. I believe they're to do with cold start, so we're just going to hook them up. The cooling system that I've built has the inlet and outlet that are required to join onto these, so it's just a couple of small rubber hoses. We may slightly re-angle that one. The next two, I'm not entirely sure what they go to, but I've got a good guess. One of them is probably to the PCV, which the Micra has in its cam cover, and the other one is most likely to a vacuum port on a brake servo. My Mini doesn't run a brake servo, so at least one of these we can remove. Probably with this back one, because the front one is on the correct size for the cam cover. To block the unnecessary vacuum port, first of all I drilled the hole out with a step drill. This gave the hole a small lip to which a plug could sit in and then be welded in. With the vacuum port welded, and at this stage being more confident with my aluminium welding, I proceeded to weld the rest of the manifold up. I'm going to end the episode here. Come back next time to see the completion of the manifold. If you've enjoyed the episode, then please hit the like button and share it with your friends. If you want to see some behind the scenes stuff and sneak peeks of up and coming episode, then follow the link which is in the description below to my build thread on the mini forum. And finally, if you want to keep up to date with this build, then please subscribe to the channel. Thanks for watching.